Hello everybody. Today we're going to take a look at a lab that involves gases. We're going to take sodium hydrogen carbonate, also known as sodium bicarbonate, which is the same as baking soda, and we're going to react it with some acetic acid. So acetic acid might look like this if it comes from the lab, or it might look like this if it comes from the store. And we're going to use those two reactants to make some gas. It occurred to me that I should really refresh your memory on what we've been doing pretty much all year. We started with atomic structure, thinking about protons, neutrons, and electrons, and we're still using that. We thought about valence electrons and the octet rule, where atoms like to get a full outer shell, either by sharing electrons or throwing away or gaining electrons. We're still using that. We need to know about proper formulas, like metals and their alloys. And we have to know about ionic compounds. Today we'll be using two ionic compounds anyway, as our reactants. And then molecules, things that have covalent bonds, things from the right side of the stair step that share electrons to make compounds. And then molar mass is also something that's really important to us today. We have to know about balanced reactions. Matter is not created or destroyed. And also, this gives us mole to mole to mole ratios when we balance our reactions. And finally, where we're at right now toward the end of the year is stoichiometry. Reactants, making products, limiting reagents, gases and percent error, and predicting how labs work. So we're going to need balance, acetic acid, sodium bicarbonate, also known as sodium hydrogen carbonate, NaHCO3. We will be using a volume measuring apparatus. This will be our reaction vessel. We'll put our two chemicals in this. We're going to make a gas, and the gas will go through the tube, and we'll take our graduated cylinder, fill it up with water, put it upside down in here so it's full of water all the way to the top, and then we'll catch some gas as it bubbles up in there. Alright, so this reaction is going to use sodium hydrogen carbonate as a reactant and acetic acid as another reactant, and we're going to make water, carbon dioxide gas, and aqueous sodium acetate. So let's go ahead and balance this reaction, shall we? We've got one sodium, 5 H's. Oxygens are good, so we have a 1 to 1 to 1 to 1 to 1 mole to mole to mole to mole ratio. That's pretty handy. Our quest is going to be to start with 0.0040 moles of sodium hydrogen carbonate. So moles is in this row all the way across, so let's write down 0.1240, so 2 sig figs in this reaction. We want to figure out how much gas we're going to make, how many liters of gas. If we have a 1-to-1 ratio, we should end up with 0.0040 moles of carbon dioxide gas. It's a 1-to-1 mole-to-mole ratio. So we want to figure out how many liters we should make, okay? So we know from our mole box that moles times 22.4 liters per mole will give us the number of liters. 0.0040 moles times 22.4 gives us 0.0896 liters of gas. Let's move our decimal 3 decimal places to get milliliters. So 89.6 milliliters of gas. Let's continue on reading this just a little bit. All right, fill out as much of the chart as you can using liters for gases only, and predict the volume of gas that you should collect. Sodium hydrogen carbonate has a molar mass of 84.0 grams per mole. Acetic acid's molar mass is 60.1 grams per mole. Water is 16 plus 1 plus 1 is 18 grams per mole. I've got that memorized. Carbon dioxide is 44 grams per mole, and sodium acetate is 82.0 grams per mole. None of these are gases except for the CO2, so I'm not going to write anything there or there or there or there for liters. Only this one, because that's the only gas that we have. The moles are all the same all the way across, 0.0040. It's a 1 to 1 to 1 to 1 to 1 mole to mole to mole ratio. So all these numbers are 0.0040, 0.0040, 0.0040. If this was a 2 here, this would be 0.00480. if this were a 2 in front of sodium acetate. Now we need to figure out the grams of all of these, the mass of all of these. So let me get a different color. We have our other circle for calculating. Moles equals grams over molar mass. Grams, cover up grams. Moles times molar mass. So 0.0040 times 84 equals, we need to start with 0.336 grams. Let's calculate the grams of this. Cover up grams, moles times molar mass. 0.0040 times 60.1 grams per mole. 0.240 grams of vinegar, acetic acid. A really cool thing to think about is in a chemical reaction, mass is not created or destroyed. So we should be able to add up all of these numbers here, the grams on this side, and compare that to the grams that we started with, and they had better be exactly the same. It says weigh out the required amount of sodium hydrogen carbonate in direction number 2. So let's put our weigh boat on there and hit tare. We'll set the balance to 0. And now we need sodium bicarbonate. We need 0.336 grams. Now our balance only goes to the hundredths place, so I'm going to have to go to 0.34 grams. And so the directions say, dissolve the sodium hydrogen carbonate in about 40 or 50 milliliters of water in a flask. And the water is not a reactant, so there's 40 or 50 milliliters. That's 40 or 50 mils, that's close enough. We want to carefully dissolve the baking soda in there. All right, swirl it a little bit, should be good. I'm going to fill up my graduate cylinder with all the way to the top. All the way to the top. All right, cover it up. Hopefully I won't get any bubbles in there. Got a couple little bubbles, but not too bad. All right, so now this is filled all the way to the top up here with water. All right, let's take about 75 milliliters of acetic acid. This will be a great plenty. This is the excess reagent. So I don't even have to, I think what I really need only about 40 milliliters, but I'm making sure I have plenty. Quickly add about half of it to the sodium hydrogen carbonate solution and immediately put the stopper on and collect the gas formed. All right, so I have to be prepared for this. I'll take the end of the hose and put it up inside the graduate cylinder a little ways, so hopefully it won't come out. And I'm ready for my reaction. Okay, so I have the sodium bicarbonate in here, the baking soda in here, and the vinegar here, the acetic acid, and I'm going to pour about half of it in there and slam the top on as fast as I possibly can. And maybe you can see the bubbles going into there. All right, are you ready? On your mark, get set, go. Okay. And there she goes. Bubbles are going up in there. Come on, bubbles. And I'm going to wait for the bubbles to stop, to slow down. That means I've run out of
something. The reaction stops at that point. Now, it could be that I've added enough vinegar that it'll go all the way to 89, I think it was 89.6 milliliters, and it'll stop right there. Or, oh no, that wasn't bad. All right, I lost a couple bubbles right there, doggone it. Okay, so is it still going? We're at about 50 milliliters right now, so that means, I guess I did run out of acetic acid, and so I will add a little bit more to make sure that that's not the limiting reagent, because the only thing that I know for sure is the grams of baking soda, sodium hydrogen carbonate, sodium bicarbonate, also known as. And the bubbles are still coming up, but it's going pretty slowly. We're running out of something. We got a limiting reagent that's pooping out in there. And bubbles are still coming.
All right, and we are now at about 62.5, about 62.5 milliliters of gas. 62.5 mils. 62.5 milliliters. How many liters is this? Well, remember, liters to milliliters is 3 away. Liters is a bigger unit, so we need less of them, so move the decimal 3 places. 0.0625 liters of gas. Okay, it's time to do our calculations right now. How many liters of carbon dioxide did we predict would be formed? I believe it was 0.0896 liters. That's how much we predicted would form, and we actually made 0.0625 liters. Now, percent yield is how much we got compared to how much we were supposed to get. So let's do that first. 0.0625 over what we were supposed to get, 0.0896 times 100. 69.7%. That's how much our percent yield was. Let's do our percent error, all right? Percent error is how much I missed by divided by what I was supposed to get. How much I missed by. All right, so I have to subtract. 0.0896 minus 0.0625. I missed by 0.0271 liters. Right, so I'm going to take that number, 0.0271, how much I missed by, divided by what I was supposed to get, which is 0.0896, and multiply times 100 because it's a percent. Describe 2 sources of lab. Well, you saw me do this. If you did this, you'd probably do a much better job than I did. I lost bubbles out of this. I'm not sure my weighing was exactly right. I only had 2 sig figs on the balance, where I was using 3 sig figs for most of the rest of the lab. It was a pretty cool lab. And remember all the things that went into doing this, the things that we've been working on throughout the entire year. You know, things like atomic structure, valence electrons, octet rule, proper formulas, formula units, molecules, balanced reactions, multimole ratios, limiting reagents, excess reagents, gases, percent errors. It's a beautiful thing, Chem, because it just builds and builds and builds, and you guys can keep going for the rest of your lives. So, thanks.